This is chapter 2.7, exercises 13 through 18. This section 2.7 of our book has to do with solving rational equations. In exercises 13 through 18, solve the equation algebraically, check for extraneous solutions, and support your answer graphically. So when we solve rational equations, what you have is unknowns in the denominator. And so we want to get our unknowns in our numerator to make the equations easier to solve, either as a linear equation or perhaps a quadratic equation. The main principle we use to solve these types of equations is to clear the denominator. And just looking at our denominator, if we look at this largest piece of denominator we have, which is underneath the 7 on the right side, x squared plus 3x minus 10. This x squared plus 3x minus 10 is a product of two factors, and these two factors are x plus 5 and x minus 2. And how do I know that? Well, we got a clue from these denominators on the left side of the equation, and so that's going to make things a whole lot easier. So if we multiply this whole equation here by quantity x plus 5 and quantity x minus 2, we're going to be successful in clearing out each one of these three denominators we have, the two on the left side, the one on the right side of the equation. And working this out, I'm just going to multiply these through, and you're going to see things just cancel all over the place. We have 3x times quantity x plus 5 times quantity x minus 2 all over x plus 5. And then we have plus 1 times quantity x plus 5 times quantity x minus 2, and that's going to be all over x minus 2. And then, I'll move this down here a little bit, give ourselves a little more room to work with. And then we have on the right side of the equation, we have this 7 times quantity x plus 5 times quantity x minus 2 all over this x squared plus 3x minus 10. Now, on the left side, we have x plus 5 over x plus 5 cancel. We have x minus 2 over x minus 2 cancel. And this factor form, quantity x plus 5 times quantity x minus 2, is the same as this in the denominator, x squared plus 3x minus 10. So we're going to cancel all this here. And so what we have left is, we have 3x times quantity x minus 2. We have plus, we have x plus 5. And we have that equal to, on the right side, 7. So we've considerably simplified. And now if we distribute our 3x times x, or 3x times negative 2 here on the left, we have 3x squared minus 6x plus x plus 5 is equal to 7. And then simplifying on the left further, we have 3x squared minus 5x, and we have plus 5 is equal to 7. And we have a quadratic equation to solve. Usually quadratic equations, we want to set one side equal to 0. So if we subtract 7 from both sides of this equation, we have left 3x squared minus 5x minus 2 is equal to 0. And now we're going to bring this here to the upper right, give ourselves some room to work with. So we have, again, 3x squared minus 5x minus 2 is equal to 0. And we're going to find the linear factors, we hope, of this 3x squared minus 5x minus 2. And to do that, well, factors of 3x squared are going to be 3x and x. And then we're going to have minus 2. Well, we need minus 5x, so I think we're going to have minus 2 over here and plus 1 over here on the left. Let me get a little more legibility if I can. Minus 2 plus 1. And then if we set each of these factors equal to 0, because of the zero factor property of algebra, we have 3x plus 1 is equal to 0. And we also have x minus 2 is equal to 0. And so just solving the one on the right here, this x minus 2 equals 0, we can solve, and x is going to be equal to 2. On the left here, we subtract 1 from both sides. We have 3x equals negative 1. And dividing both sides of this equation by 3, we have x equals negative 1/3. So now we're going to check for extraneous solutions. Now, what is an extraneous solution? An extraneous solution is a solution that is not real, but one that is created in the process of solving an equation. And you see these sometimes in solving, in this case, rational equations. It can also happen quite often solving logarithmic equations. And basically, to check them out is we place these solutions back in the original equation. So if we take this x equals 2 and replace this one right here with 2, we will have 2 minus 2. 1 over 2 minus 2, well, that'll be 1 divided by 0. So is anything divided by 0 defined in mathematics or in algebra? No, it's not. So what we say is this solution here, x equals 2, is an extraneous solution. And these extraneous solutions in these rational equations usually come out like this, where you can easily spot them because you'll see that dividing by something substituted in for that isn't going to work. The last thing we're going to do, it says support your answer graphically. And for graphical support, we have this calculator. I had installed this equation earlier, and before I press enter, let me just explain. The way to solve these equations graphically, the best way I've found, is if you set one side of the equation equal to 0. So to do that for this original equation, we're going to have 3x over x plus 5 plus 1 over x minus 2. And then we want to set this right side equal to 0. And to do that, we subtract this 7 over x squared plus 3x minus 10. And having done that, we've set this thing equal to 0. We enter this as a f of x as a function, and we graph that in our calculator. So again, we set one side of this equation equal to 0. We graph this. This is what the equation looks like entered, and we press enter. And we see that between negative 1 and 0, in fact, we can go look at this. We can go analyze graph 0, and it says lower bound, right bound, and so we have a 0 at negative 0.333, negative 1/3. And we see at x equals 2, which was our extraneous solution, we don't have the graph of the function close to that x-axis. So basically, when you solve it this way, you're looking along the x-axis for your real solutions. And so what this ends up being is a verification. And so we say our solutions are x equals negative 1/3 and x equals 2 also, but specifying that x equals 2 is an extraneous solution, one created in the process of solving the problem. Next on problem 15, we use the same principle, clear the denominator, and it so happens that this in the denominator x squared plus x is a factoring of, the factoring is x times quantity x plus 1. And we hope this would be the case. And so if we multiply this whole thing by the whole equation by x times quantity x plus 1, we are going to be successful in clearing out our denominator. And now rewriting, we have x minus 3 times quantity times x times quantity x plus 1, and that's going to be over x. And we have minus 3 times x times quantity x plus 1 over x plus 1. And then we have plus 3. We have x plus 1 over x squared plus x, and that's going to be equal to 0. We multiply this right side by the whole equation by 0. The right side still remains 0. And then we can cancel. We have x over x canceled here for this term on the left. We have x plus 1 over x plus 1 cancel each other. And then we have x times quantity x plus 1 cancels this x squared plus x in the denominator. So what we have left is we have x quantity x minus 3 times quantity x plus 1 minus 3x plus 3 is equal to 0. And just multiplying this out, we have we can do different ways. We can do this FOIL type operation here. One way of doing this. Not a big fan of FOIL, but in this case we're going to do it just to speed things up. So we have x squared minus 3x plus x minus 3, and then we bring, that's this whole thing worked out, and then we have minus 3x plus 3 is equal to 0. And we have negative 3 plus 3 cancel each other, and we have left x squared minus 3x plus x minus 3x. What we have left is x squared minus 5x is equal to 0. And to solve by finding the greatest common factor, we have x times quantity x minus 5 is equal to 0. So just working these out, we have our solutions are going to be x equals 0, and our other solution will be x equals 5. So those are our solutions, and we see if we plug in 0 here for x, that's not going to work out because we can't divide by 0. So these are solutions, and we say the solution x equals 0 is an extraneous solution. And then the last thing we're going to do is check our calculator. If I go to Control-I, add graph, get our second equation entered here. The equation was already solved for 0, but we see a solution here. It looks like at x equals 5, and if we go to Control T to look at our table view, we scroll down to x equals 5, we have an output of 0. So again, this confirms what our answers are, and here they are boxed in. Now, one more odd number problem, which is 17. Again, we're going to clear the denominator, and we hope to notice that we have x squared plus 2x is equal to x times quantity x plus 2. And I hope you can see how that's going to be helpful to us here. So again, now multiplying this whole equation by x times quantity x plus 2, we're going to have 3x times quantity x plus 2 over x plus 2. And then we have plus 6x, 6 times quantity x times quantity x plus 2 over x squared plus 2x. And now on the right side of the equation we have this 3 minus x that I wrap inside parentheses times x times quantity x plus 2, and that's going to be all over x. And then we cancel what we can. We have x plus quantity x plus 2 or x plus 2 cancel. We have x times quantity x plus 2 cancel this x squared plus 2x in the denominator. On the right side we have x over x cancel. And so what we have left is 3x plus 6 equals, we have 23 minus x times quantity x plus 2. We can do just like we did in our previous problem and distribute this out. And that being the case, we bring down the 3x plus 6, and on the right side we have 3 times x is 3x. We have negative x plus 2 is going to be minus 2x. We have negative x times x is going to be negative x squared. And we have 2 times 3, which is 6, as in plus 6. So just simplifying, we have 3x plus 6, and we have 3x minus 2x is going to be x minus x squared plus 6. So if we subtract 6 from both sides of this equation, we have cancellation here. And so there are different ways of doing this. I'm just going to also subtract 3x from both sides of this equation. So what we have left on the left side now is 0 is equal to x minus 3x is going to be negative 2x and minus x squared. And if we factor out a negative x, we have left x plus 2. You see, if we multiply these back together, we're going to get negative 2x minus x squared. So, coming up here to the upper right, we have 0 equals negative x times quantity x plus 2. And then we have x is equal to 0 as a solution. And also we have, if we solve for x, we have x equals negative 2 as a solution. And if we plug back in to our original equation, if we substitute in x on the 0 for x here, dividing by 0, that's not going to work. So 0 is an extraneous solution. If we take x equals -2 and plug it in here on the left term, -2 plus 2 equals 0, that would be a division by 0 also. So we say that both are extraneous solutions. They are solutions, but not real solutions. And the very last thing we're going to do is check graphically, and we press Control I, add graph, and here we take a look. This is our third equation. Again, solve for 0 on one side. We subtracted this 3x minus x over x to set one side equals 0 and set the other side, replace 0 with f of x. And we get a horizontal line at y equals 1. So that shows no real solutions. So that is a confirmation. So we're going to box these solutions in. Be careful in our boxing. Here we go. And these are the odd number problems work out. Good luck in working out your even number problems. And as always, thanks for viewing.